Okay, welcome to the second section of Chapter 3. This is also going to be somewhat review from Algebra 1, and this is going to be solving systems of inequalities by graphing. So here are our objectives for this section. We're going to solve systems of inequalities by graphing. So these are inequalities, not equations. And we're going to determine the coordinates of the vertices of a region formed by graphing a system of inequalities, which I will show you what that means a little bit later. So our vocabulary for this section is just system of inequalities. Just like a system of equations, a system of inequalities is a set of two or more inequalities that have the same variables that we're solving together at the same time. So basically there are just two steps to solving systems of inequalities. I have to graph each inequality separately. I graph them on the same axes, but I graph them one at a time and I shade the correct area. And then I identify the region that's shaded for all of the inequalities, or basically where the shading overlaps. And that section of the graph is the solution of the system. If you remember, when we graph just a singular linear inequality, we always shaded one side, right? When I graph a second inequality, and then I shade that side, I'm basically looking for where the shading overlaps. So I'm looking for the region that is true for both linear inequalities. Or more than two, because sometimes we'll do 3 or 4. All right, so we're going to solve this system of inequalities by graphing. Y is greater than or equal to 2x minus 3. That's the first one we're going to graph. Greater than or equal to means it will be a solid line. My y-intercept is -3. My slope is +2. So I go up 2 to the right 1, and I continue that to make my line as straight as possible. And then I'm going to connect that with a solid line. And now I just have to decide where to shade. Since this line does not touch 0, 0, I'm going to plug in 0, 0 for x and y. And I'll get 0 is greater than or equal to -3. That is true. So that means that since 0, 0 is on this side of my line, I need to shade this side, right? So I'm just going to carefully shade it in. If you're doing this with pencil, I would suggest just lightly shading it so that it will be easy to see where the overlap is. The biggest thing about graphing systems of inequalities is that I need to be able to tell where the solution area is, okay? So now we're going to graph our second inequality. Y is less than -x plus 2. This will be a dotted line because it's strictly less than, not less than or equal to. So there's my y-intercept of 2 and a slope of -1. And then we're going to connect those with a dotted line. Now that I've done that, I'm going to plug in 0, 0 to this one. And I'll get 0 is less than 0 plus 2. 0 is less than 2. That is also true. And since 0, 0 is on this side of the blue line, I need to shade everything on this side of the blue line. Okay, so again, carefully shading so that you can see where the overlap is really easily. Notice there are 4 sections that are created when I graph 2 lines. I have one section here, one section here. That's obviously not the solution. Nothing there is shaded. One section here and a section here. This is the section that is the solution because it's shaded in both blue and red in this case. It's the only section of the graph that's true for both inequalities. So any ordered pair in this section, this is kind of hard to shade in quickly, sorry. Any ordered pair in this section is going to be true for both inequalities. So that means that this section is the solution set. Here it's graphed a little more beautifully. You can see the 4 regions really clearly. This green region represents our green region that we just graphed. It's the overlap of the blue and the yellow region. So this region is the only place that is the solution set of the system of inequalities. Okay. Notice that this region still has infinitely many ordered pairs because the region goes on forever, since both of these inequality boundary lines go on forever. So there's an infinite number of solutions, but they can only be in this region. If I pick an ordered pair from here, it will make my second inequality true, but not the first one. I have to pick an ordered pair from this green region. Okay, I want you guys to stop and try this one. Okay, you should have gotten B. All right, let's solve this one by graphing as well. I'm just going to show you real quick what this looks like. Notice that both of these inequalities are in slope-intercept form. So the slope of this first inequality boundary line is -3/4, and the slope of this inequality boundary line is also -3/4. So I automatically know they're going to be parallel lines because their slopes are the same and their y-intercepts are different. So if I look at this inequality first, here's my y-intercept of 1 and a slope of -3/4. So I can go up 3 and to the left 4 or down 3 and to the right 4. Solid line because it's greater than or equal to. And when I plug in 0, 0, I get 0 is greater than or equal to 0 plus 1. I get 0 is greater than or equal to 1. That is false. And so instead of shading the side with 0, 0, I shade on this side. And you can see that they have already done that here for us beautifully. When I graph the second one, I have a y-intercept of -2 and a slope of -3/4 as well. And this time, when I plug in 0, 0, I get 0 is less than or equal to 0 minus 2. 0 is less than or equal to -2. That is also false. So I have to shade this side. I have to shade the side that does not contain 0, 0. So if you'll notice what happens here, the graphs don't overlap, right? This parallel section here in the middle, well, because they're parallel lines, they never touch, and since I shaded above the line on this one and below over here, my shading never overlaps. So there is no solution to this system of inequalities. And this is the only way that there can be no solution, when the lines are parallel and when I shade in opposite directions. Because sometimes, for example, if I had had to shade on this side of the line, I would have gotten overlap on this part right here. But because I shaded in opposite directions, there was no overlap, therefore there was no solution. All right, try this one for me. Okay, you should have gotten A when you graphed this one. If you'll notice, when we graph both of these inequalities, we again have the same slopes and different y-intercepts, so we know they're going to be parallel. Here is the first inequality that I'm graphing, dotted line, and you end up shading below the line there. Sorry, let me get all the way up to the line. The shading is not beautiful, but hopefully you guys will forgive me. And then when I graph the second one, y is greater than 1/2 x plus 2, there's my y-intercept. I graph the points with a slope of 1/2, and again I make a dotted line. And notice that the blue shading goes all the way up to the green line. I didn't do a very good job of showing that. When I shade for the red, I shade above the red line. So I shade this way. And the only overlap is between my two parallel lines. So I shade that in darker if you were just graphing this on a test or a quiz or on your worksheet or whatever. So in this case, because I'm shading so that there's overlap, that overlap is the solution. So this one actually does have a solution region, whereas the one on our previous slide looked more like C that did not have any solution. All right, let's take a look at example 3. I'm going to pause and give yourself a second to read this. All right, so we're talking here about medicine, medical professionals. They recommend that we have a certain level of cholesterol that needs to be below 200 milligrams per deciliter and a triglyceride level T below 150 milligrams per deciliter. So we're going to write a system of equations. Of inequalities. So our C, which is the cholesterol level, needs to be less than 200 milligrams per deciliter. We also know cholesterol can't be negative, so this first inequality is going to look like this. C has to be greater than or equal to 0, but less than 200. Now T has to be less than 150 milligrams per deciliter. They also can't be negative. So T, our triglyceride level, has to be less than 150, but greater than or equal to 0. So we write it as a compound inequality like this. And when we graph basically what we're going to do is we're going to graph this completely in the first quadrant. So that takes care of those zeros, right? C and T both have to be positive, so I'm only going to be in the first quadrant of my graph. So we're going to make T our x-axis and C our y-axis. When I graph the inequality C is less than 200, that's the same as saying Y is less than 200. Remember that if Y equals a number, it's a horizontal line. So this is going to be a horizontal line, but it's going to be dotted, and it has to be less than that, so we'd shade below. And T has to be less than 150, because we already took care of the greater than or equal to 0 by keeping it in the first quadrant. Since T represents x, x equals 150 would have been a vertical line. So T is less than 150 is a vertical dotted line, and we have to shade less than. So basically what we did is we shaded less than 200, which looked like this, and it would go all the way across. So we can see this a little better, hopefully. And when I shade less than 150, this side to the left is all of the values less than 150. And you can see that the overlap is here in what the book shaded as blue. All right, I want you guys to read this one, and then I'll move to the next slide, and you can answer which one you think matches the best. Okay, give me your answer. You should have said A. If you notice here, the wind speeds have to be between 111 and 130. So the wind speed here was the y-axis. So between 111 and 130, those are my horizontal lines. And I would have to shade between them. And then S represents the storm surge. Has to be between 9 and 12. Those would be vertical lines because those are representing x equals 9 and x equals 12, and I would shade between them. And this little rectangle here in the middle would be my overlap. That would be my solution region. All right, finding vertices. This was our second objective that I told you we would talk about later. Basically what we're trying to do is we're going to graph all three of these inequalities on the same axes, and they're going to form a polygonal region. So it's going to make a polygon that will be my solution set, and I need to find the coordinates that are the vertices of the polygon. In this case, it's going to be a triangle. So we're going to graph each inequality. Let's just look here real quick at each one. Our first inequality is 2x minus y is greater than or equal to -1. So notice here I put it in slope-intercept form to be able to graph. Be careful because here I got -y is greater than or equal to -2x minus 1. And when I divided everything by -1, it switched to less than. So that's this inequality here, a y-intercept of 1 and a slope of 2. And if I shaded this one, it would be shaded below the line in this direction. Okay, and here I've solved both of those inequalities for slope-intercept form, so you can take a look at that. Here's the x plus y equals 4 boundary line, so since that's less than, I would be shading below that line here. And then last but not least, here is my third boundary line. X plus 4y equals 4, that's the boundary line, and since it's greater than or equal to that, we end up shading above the line. So you can see that when you do all of the shading actually yourself, it gets kind of messy, but this blue region here in the center is where all of those shadings overlap. So I'll erase all of my crazy shading because that's not going to be very helpful to see the vertices, but you can see that my solution area has 3 vertices, 0, 1, 1, 3, and 4, 0. Those are the vertices that they want us to write down. And you might wonder, why are we doing this? Well, part of it is because being able to write down the vertices means that you are precise in the way that you solved. The second reason is we're going to apply this concept of vertices in our next section when we talk about real-life applications of systems of inequalities. And the vertices are going to help us find maximum and minimum values for different real-life situations. Okay. Last example for this PowerPoint, go ahead and try this one. So you should graph those 3 inequalities and get the vertices. And the answer is C. Again, you got a triangle for this one, so you should have 3 vertices, -1, 1, 0, 3, and 5, -2. That's the end of this video. I will see you in class to practice, practice, practice.